So, what is a heat map? Is it a map that shows you how hot it gets in different regions? Well, kind of, but also not really. In this video, I'll show you how you can create this map with a few lines of code and even split it by seasons with a few more. I will also teach you how you can use the geom_tile function to create heat maps to visualize, for example, weak and strong episode ratings of TV shows. And after that, I will show you how the heat map function works to find patterns in the performance stats of NBA players and how they relate to their different positions. Let's start with the R code. There are many different ways to produce maps in R. In the description, I will link to a site that shows you different packages to accomplish that. One of the easiest ways is to use the USMap package. This has a built-in function called plot_USMap that only needs a data frame that has the state information and a value to be plotted. So in this case, I have a data frame of the 50 different states and their annual temperature in Fahrenheit. With labels equals true, you get the two-letter code of different states, and it even moves Alaska and Hawaii right below the US map. The good thing about the plot_USMap function is that it works within the context of the ggplot functions, which you can load separately or you have it already included in the tidyverse package. And here we can add to the basic plot. For example, by using the scale_fill_continuous function. The used temperatures are on a continuous scale. And with this function, we can fill it starting at a low value green up to a high value red. And with name, we can give the legend a title. Then with the labs function, you can give the whole chart a title. And with the theme legend position equals right, you move it from the default to the right of the chart. Now I wanted to improve this map a little bit further because sometimes this continuous scale can be hard to decipher to really see the differences between the different shades of orange. So what you can use is the scale_fill_steps_n function, and with that you can say how many breaks you want to have for the continuous variable, and then it will create different buckets of temperatures, and now you only have 7 distinct colors for the different states. I also excluded Alaska and Hawaii because their temperatures are too extreme to compare it to the other states, and you can do that within the plot_USMap function by simply using the exclude argument. Then it's good practice to leave a note in the subtitle of the charts explaining what you did, and I think for only using 4 different functions, that's quite a decent visualization of the annual temperature of the United States. I also have a data set called USTempSeasonal that includes every state 4 times with the average temperature for different seasons: fall, spring, summer, and winter. With the forecats package, you can make sure that these seasons are not plotted alphabetically, but actually with the order in mind, going from spring to winter, for example. And then the only thing you have to do additionally is to use the facet_rep function till the season to split the same chart for the 4 different conditions. And you can give the numbers of columns you want to have to get this nice quadrant of the different temperatures and seasons. You do have to exclude Washington, D.C. because if you don't, it will generate an extra map by default that's not represented in the dataset, and then you have no season for DC plotted in an extra subchart. If you want to create a map that Europeans would understand, you can have another column created called temp_C for Celsius. Use this formula to convert Fahrenheit to Celsius and then just change the values to be plotted. And then you would have it on a scale that non-US citizens could understand. Now let's move on to the geom_tile function that I will use to visualize different IMDb ratings for several TV shows. The data originally comes in this format that has the episodes as rows and the seasons as columns. Here for Breaking Bad and here for Game of Thrones, which went on for 8 seasons but had fewer episodes per season. And for geom_tile to work in a ggplot context, you have to first transform the wide data frame into a long data frame format, which you can do with the pivot_longer function. This is the wide data frame, and with pivot_longer, excluding the episode column, it will gather all of these columns and put them under one another. So now you have 5 times episode 1 because it was the first episode in 5 different seasons, and then you have the value. And this goes on for 70 more rows. What I then do is to use the setNames function to turn this into episode, season, and rating, and then I divide the rating by 10 to get to these decimals that are on a 0 to 10 scale. And I do this within the mutate function and store the whole thing in the IMDb Breaking Bad long data frame. Then I repeat that for Game of Thrones and for Ozark. Now based on this long data frame, I use the ggplot function and do the aesthetics mapping, where the season is on the x-axis, the y-axis holds the episode. I need a label for the rating to be able to plot the numbers. And for fill, I use rating, but when I come to the geom_tile function, at first I overwrite this filling with white, and color gray is for the borders in between the the cells. So now if you just have the numbers, it's not easy to see which episodes are above average and which are below, or to detect patterns. The scale x discrete function is used to move the x-axis label on top, and the scale y discrete is used to have the order not going from 1, 2, 3, 4, 5 up, but from 1, 2, 3, 4, 5 down. So if you would just run this code, it would look like this, with increasing episode numbers and seasons. This is what you would get for Game of Thrones, and it's also not easy to see which episodes did well. So let's add some colors. The only function you need to include is, for example, the scale fill continuous function. The rating is on a continuous scale, and with this you can specify a low point, in this case orange, and a high point for dark green, and then you can give the legend a title, IMDb rating as name. The geom text I add in white now, because it's easier to read this way, and the rest remains the same. And now you could easily see that usually Breaking Bad ends on really strong episodes, kind of cliffhangers that want you to watch the next season. And then season 5 was overall very green and good and ended extremely strong with almost perfect ratings for the last 4 episodes. You can do the exact same for the Game of Thrones data, and then you see that usually as well the last episodes of the season were really strong, and you can also see that season 8 kinda stank. But now we face a problem that I should address. If you would just compare these different charts, then it would look like that Game of Thrones was overall better because there's more green, but the average rating for Breaking Bad was actually slightly better than for Game of Thrones. And ggplot will use the smallest value and the largest to come up with this color scale. And since it spreads out for Game of Thrones down to 4, most of the higher rated episodes get a very strong green. To fix this, there are 2 different ways. For example, what we can do is to merge both data sets. We can pipe the Breaking Bad long data frame into mutate to assign a series name, and then row bind it with the Game of Thrones data frame, where we also mutate the series name to be Game of Thrones. And then we have a combined data set, which would look like this. So different seasons and episodes and ratings, one time for Breaking Bad and one time for Game of Thrones. And now if you plot them together, you should have the same IMDb rating scale and a better way to compare them. So the only thing we have to add now is a facet wrap based on series, which again holds the name, and then it will create 2 charts with the same legend. If we zoom in, it would look like this. So now much better to compare the high performing episodes with the slightly worse ones, and you can see that both series are very strong. Now facet wrap will keep the X and Y axis constant between different groups, so showing more episodes for Game of Thrones, which they didn't have, and more seasons for Breaking Bad, which they didn't have. And you can overcome this by changing facet wrap to something where you free the scales. You can free both scales, but if you only free the X-axis, then it will stop at season 5 for Breaking Bad. But if you want both axes to be free, just use free, and then you will have Game of Thrones only extending to episode 10. Another thing we can do is to fix the scale of the color gradient. We could already do that in the facet wrap combined visualization, because now that Game of Thrones is included with these low ratings, everything else becomes pretty much greenish and hard to compare. But we could use limits 7 to 10 within the scale fill continuous function to put 7 as the low point. Now of course everything below 7 has no color, but now it's a little bit easier to compare strong parts of the show that are more dark green, and you can see that Game of Thrones had these highlight episodes like the Red Wedding or strong closing of season 6 that popped up in between. And you could use this for the Breaking Bad data only, where you say, okay, to have it comparable to Game of Thrones, I needed to go down to 4, even though none of the episodes is that lowly rated. The smallest is 7.9, but now this gets a nice green already because 4 is the low point. One tip I want to show you to save some lines of code: you could save the plot in a basic format like this. So Breaking Bad plot is everything except the actual color coding. Ctrl-Shift-C comments out this part, and then you store this, and when you plot it you get the default. And now what you can do to this object is to add a color function like scale fill continuous, and you don't have to repeat the whole ggplot code if you want to switch to another coloring function. And another one I want to show you is the scale fill gradient 2 function that actually comes with a midpoint. So you could use a color for a midpoint and then red for really bad episodes, and you can specify the midpoint rating. So now you would get something like this, and then it's really useful to extend it to another show like Game of Thrones. Now you have a nice differentiation between the medium episodes in orange or yellow, close to the midpoint, and then the lower rated ones get a red. And this can also help you to compare it to a completely different show like Ozark that was on average rated 0.5 points worse than Breaking Bad and Game of Thrones, and you can see that it only really picks up in the 3rd and 4th season of the show. but you could also use the old trick to combine the different data sets and then plot them next to each other with facet wrap. Now we will come to the heat map function, which is natively provided by R and has tools to normalize input data, run clustering algorithms, and visualize the results with dendrograms. In order to work, the data needs to be in the format of a matrix, and it needs to only contain numeric values. So the empty cars dataset is currently a data frame with the name of the cars in the rows, so all the columns hold numeric values, but for heat map you first have to transfer it into a matrix. So with str empty cars you see it's a data frame with all numeric columns. If you turn it into a matrix, it looks like nothing has changed much, but the structure is now a numbered matrix with 32 rows, 11 columns, and it has extra attribute information with names for the 2 dimensions, the column headers and the row names. If you just run it without any other arguments, this is the result, where small values have this pasty yellow and high values get this dark red and purple. And this is because some of the variables are coded with zeros and ones, so very low values, and some have high numbers like the displacement or the horsepower of the cars, so these get intense colors, which means that we need some kind of normalization. We want to know within each column which are the highest values and which are the lowest, so you can use scale on the column to get this result. And now in the 0, 1 columns you just have 2 colors, but columns with multiple values have some more details included. By default, the heat map function will introduce some ordering of the rows and columns based on the correlation of their values, and then it will create these dendrograms where it will group similar columns together as well as similar cars. Displacement stands for the volume of the engine, so the more cylinders you have and the bigger they are, the bigger is your engine, and this correlates very strongly with the horsepower. A bigger engine can generate more force. This is negatively correlated with the mileage, so a bigger engine usually won't get you that far with the same gallon of gas. And there's also a negative correlation with the weight, so the heavier you are, the smaller your mileage is. And then you see some clustering on the cylinders, so we have 8, 6 and 4 cylinders, and somehow these cars are more similar. And you can also see that there's a big cluster of cars that have automatic transmission, here coded as 0, or manual transmission. If you don't want the reordering or dendrograms with the heat map, you can say col v and row v equals NA, and then you have the order of the original data frame where the cars go from the Mazda RX-4 to the Volvo 142e, and the columns come out in the same order, miles per gallons to carb. You can also be selected and only keep the column ordering and dendrogram. Now the rows will remain the order of the data frame, but the columns get reorganized based on how close these values are to each other. But now it's a bit more difficult to detect patterns for the different groups of cars. Similar to the plot function, you can make use of the main function argument to give the chart a title, and you can also choose xlab to label your x-axis. The heat map function of course comes with a help documentation where they go through all the different function arguments, and for the next example I want to show you how you can use column side colors and row side colors to visualize patterns in NBA player statistics. I have the following information on NBA players and their average statistics per game. You see the name, the position, age, the team they play for, the games they played and the games they started, as well as the minutes played. Then statistics on field goal attempts and the percentage the attempts went in, the same for 3-point attempts and percentage, 2 points, effective field goals and then free throws, as well as offensive, defensive and total rebounds, assists, steals, blocks, turnover, fouls and points. And now I want to make a heat map for those stats, but only for a certain number of players. The ones from teams that made it into the playoffs, that played at least 60 games and for 18 minutes on average. So these are the teams that made it into the playoffs, and now I filter for at least 18 minutes played, 60 games in total and the playoff teams, and I count the positions that remain. And the reason is I want to look for patterns in these player stats giving the position that they play, and this is a good enough sample size to still visualize and look for similarities. One thing that's already obvious from the dendrograms is that the defensive rebounds and the total rebounds correlate strongly, as well as the field goal attempts and the points. So the more you try, the more often you hopefully hit. And then you also have this group of 2-point attempts, 2-pointers made and field goals made in total that cluster together, as well as all these percentage stats. There was a little bit of data wrangling I had to do. First I created a position name variable that pasted together the position of the player and the name separated by a dash, so I could still see who is center, who is point guard. And then later I want to visualize these positions with a collar that runs on on the side of the dendrograms, and for that I created a side color variable with the case when function, which just says if the position is center, choose red, if it's point guard or shooting guard, blue or light blue, and if it's power forward or small forward, dark green or green. Then I put row names on this new data frame that comes from the position name that I just created, and then I turn this data frame into a matrix called NBA heatmap, where I only select the columns that hold numeric values. So everything from field goal to points goes into the matrix, because we cannot have all these text variables included. And here's where it starts with the average per game values all the way down to points. And then you can use this heatmap function to produce this chart. The kex row decreases the size of the player name, otherwise it would skip every other one. And now I want to do three things: change the color, add color to the row and the column, and then include legends. As usual, there are different ways how you can change the color in R. One is with a natively available color palette called CM Colors or Terrain Colors. And there's also the Color Brewer package that I will use for the next examples. I will also link to a short description of it that shows you from which color palettes you can choose. And here I choose this palette one time with 25 different steps in between the most purple and the most green, and one time with only 4 steps. So you have some flexibility here, how fine-grained you want the differences to be. But then I thought, if I make a visualization about NBA statistics, why not choose the blue and the red as the extremes? And they come with a hex code that you can use within the color ramp palette function, where you choose 2 colors as the extreme ends of the palette, and then you give how many steps you want to have in between them. So 11 will get you 11 different values that are between this blue and this red. And it's kind of informative, but I think we can do better with including white as the center point, and then everything that's red is above average and everything that's blue is below average. So you just use the color ramp palette function to go from blue to white in 6 steps, but then exclude white by only choosing the first 5 colors, and then you repeat the same with white to red, but then take all 6 of them and combine it in a vector color 1, color 2, and then you get this pattern where you can already see some clusters of high performance players and some players that are below average compared to other players. Now remember that I created this extra color vector called side colors in the NBA data frame, and I want to use it now. And it's really easy to do. There's a function argument called row side colors, and you just give it a vector of colors that has the same order as the original data matrix. And if you zoom in now, you can, for example, see that there's a big cluster of shooting guards visualized by this light blue. And here you have a cluster of green and dark green, small forwards and power forwards, and then there's also a big cluster of red for center players. You can use the legend function to keep track of this information, give it a title like position, and then use the exact same colors from red to green along with the legend text that explains the different positions, and this will look a lot better when you export it as PDF or zoom in some more. And then I also wanted to introduce a color coding for the columns, and the NBA heatmap data matrix has named dimensions for the column names, and you can access these with the attribute function and then ask for the dim names with which, and select the second item, which stands for columns. First is rows, which has the player names. Second is columns, which holds the stat names. And then I wanted to see if these names are in this character vector that holds defensive rebounds, steals, blocks, and fouls, which I consider defensive stats. And if that's true, choose yellow, otherwise use dark green, which gives you this color vector that I will use for the columns now. So additionally to the row side colors, I now have column side colors to show you that some of the defensive stats cluster together. And then I wanted to have a legend for that as well to put on the top right. Now, is there something you can conclude from this heat map? Especially if you're not really familiar with basketball or what these positions really mean. So there's one thing I find striking. There's a group of players that does exceptionally well when it comes to pointing, mostly due to their field goal attempts, sometimes caused by many 3-pointers and turnovers. And it's not necessarily that they also score a lot percentage-wise from their attempts, but that they just try a lot more. You can also see that these group of centers are really good when it comes to offensive and defensive rebounds and blocking, but not so good with their success from the 3-point line, which makes sense. And as I already mentioned, there's some grouping of the positions, some blues that are together and some greens, but it's not a clear cut. Stats wise, some of these centers are closer grouped with forward positions and sometimes even the guard positions, but you can also see a tendency of why the center position is so special compared to the other ones. So this was a basic introduction of the geom tile and the heat map function to visualize continuous variables for multiple categories. To learn more, you can of course go to the rgraph gallery, where you learn how to make this hourly temperature visualization over 2 years for each day of the years on a 24-hour time frame. If you're interested in really complex heat maps, there's a whole book written by Zhuangguang Gu with multiple chapters and many examples of advanced heat maps. For example, for genomics data, heat maps there are quite common, for example, to show over or under expression of genes in healthy or tumor cells. And you can of course search for heat maps in R, where you find multiple good videos with various examples to give you a good start and overview on your heat map journey. Thanks for watching. Until next time, here at the Data Digest.